So let's take a look at graphing secant. This is the part we didn't finish up in class, so let's take a look at it together. So again, to graph secant, we're going to start with the reciprocal of the function, which is cosine, which we already know how to graph, and we're going to do the reciprocal or flip of that graph. So let's take a look at how that goes. So at 0, our cosine is at 1, our x-coordinate is at 1, so cosine starts at its maximum. When we make that a fraction, 1 over 1, and flip it, it's still 1, so secant is also at 1. At pi over 2, our cosine is at 0. That's our x-coordinates at 0. When we make that 0 over 1 and flip it, it becomes 1 over 0, which of course division by 0 is undefined in our number system. What happens graphically when we have division by 0? We get a vertical asymptote. So at pi over 2, secant has a vertical asymptote. At pi, our cosine value is -1. When we do the reciprocal or flip of that fraction, it's still -1. So at pi, our secant is at -1. At 3 pi over 2, cosine is back to 0. Again, when we make that a fraction and do the reciprocal, that's going to generate division by 0, which is undefined in our number system. That's going to create a vertical asymptote on the graph at 3 pi over 2. And then at 2 pi, our cosine is back to +1. When we do the flip of that, that's still 1. So at 2 pi, we're at 1. Okay, those are 5 critical values: maximum, asymptote, minimum, asymptote, maximum on the cosine. This won't be the maximum and minimums on these sections of our curves, or they will be, but in reverse order. What we're going to do here is take a look at a couple more values. So when our cosine is at 1/2, our secant is at 2 over 1. When our, so everywhere where our cosine is at 1/2, our secant is at +2 over 1. Everywhere where our cosine is at -1/2, our secant is at -2 over 1. So everywhere where cosine is -1/2, secant is -2 over 1. So when you go ahead and connect those points with a smooth curve, it's going to be approaching there, there, and there. You could do some more numbers if you wanted, like when it's at 1/3, it's up at +3. So you can see when it's at 3/4, it's at 4/3. Okay, so you could add more points if you wanted to see that, but that's what it's going to do. It's going to flip that graph. Okay, so similar to when we were graphing cosecant, everywhere where the reciprocal function, which in this case is cosine, is at its midline, everywhere where the reciprocal function is at its midline, we're going to generate the vertical asymptotes in the secant function. And then when it's up, we'll flip it up. And when it's down, we'll flip it down. Okay, so it's the reciprocal function, and the graph is a flip of it as well. Okay, period of the function is still 2 pi. Domain is going to be all real numbers such that x does not equal. Where do those asymptotes happen? They're happening on the half pi's. So I'm going to call that pi over 2 plus k pi, where k is an element of the integers. Okay, so if we start at the half pi's and go forward a full integer pi, so forward 1 pi, forward 2 pi, we'll land on another asymptote. So that's one way to represent that. The range is going to be from -infinity non-inclusive up to -1 inclusive, union with 1 inclusive to infinity. Our asymptotes happen exactly where our domain was restricted, so we're just going to copy it from there. Instead of not equals this time, so it's what x does equal. X equals pi over 2 plus k pi, where k is an element of the integers. Element of. Okay, our x-intercepts, there are none. You can put the empty set or does not exist or not applicable. This function, let's go ahead and graph a second cycle so we can see what that looks like. So everywhere where cosine is at its midline, we're going to get a vertical asymptote. And when it's up, we're going to flip it up. And when it's down, we're going to flip it down. When it's up, we'll flip it up. Okay, so that's that second cycle. We can see from this that this is definitely an even function. It is in fact symmetric about the y-axis. You can fold it right across that axis and those two cycles lie on top of each other. That'll help us when we're dealing with a negative b value on the coefficient. We'll use our even and odd properties to help us know how to handle the negative when we see that. Intervals of increase and decrease, I like to highlight them. So I have an interval of increase, 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 increase. Let's look at our intervals of decrease. So decrease, oops, wrong color. Decrease, 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 decrease. So we move left to right. The color coding really helps me keep them straight. So we set our intervals of increase, dot, dot, dot. They're going to start at -2 pi inclusive up to -3 pi over 2 non-inclusive, because that's where my asymptote is at. Union with -3 pi over 2 non-inclusive, because that's coming from the asymptote, towards -pi inclusive. Union with 0 inclusive to pi over 2 non-inclusive, because that's where the asymptote is, so we never actually reach that value. Union with, coming from the other side of that asymptote, pi over 2 to pi inclusive, and a dot, dot, dot to show that that pattern continues. Our intervals of decrease, let's take a look at that. That's going to be from -pi inclusive to -pi over 2 non-inclusive, union with -pi over 2 non-inclusive to 0 inclusive, union with pi inclusive to 3 pi over 2 non-inclusive, because that's where the asymptote is, union with 3 pi over 2 non-inclusive to 2 pi. And that's inclusive, and the ellipsis dot, dot, dot to show that that pattern continues. Okay, and our y-intercept, you can see it right there on the y-axis. X is 0, y is +1, just that single point. Our steps for graphing the secant and cosecant are going to be to get the equation in graphing form, plug in the reciprocal function and graph that with a dotted line, then draw vertical asymptotes where the reciprocal function is at its midline, and flip the sections of the graph up. If it's up, it'll flip up, and if it's down, it'll flip down. So let's try an example of a secant graph with transformations. So it's not in graphing form, so we're going to get it ready. It's going to be y equals -2, secant is okay, parentheses, factoring out that leading coefficient on the x, so that's -3 out x. Now factoring it out is dividing it out, so -pi divided by -3 is going to be +pi over 3. You can check that factoring by redistributing. So -3 times +pi over 3 would be -pi, so that is correct. And then we've got that +1 that's moving to the end there. Okay, it's still not in graphing form because we have a negative b value, so we've got to deal with that negative b value. We said that this function is even. Remember that for even functions, f of -x is the same as f of +x. So if we have a negative b value, we can just drop the negative, okay? So we can just drop it. So this becomes y equals -2 secant +3 x plus pi over 3 plus 1, okay? Using those even properties to handle that negative b value. All right, now, so now it's in graphing form, it's ready to go, but we need to use the reciprocal function. So we're going to do the exact same transformations on the cosine function and graph that first with a dotted line and then flip it to get our reciprocal functions graph. Okay, so let's give that a try. I'm going to use my mappy now. My midline is at +1. Okay, so I'm going to put my x-axis just a little bit low so that 1 can be in the middle of it. Okay, my amplitude is going to be 2 because it's always positive. So I'm going to go up 2 to 3 and down 2 to -1. My phase shift is -pi over 3 because remember inside is the opposite of what it looks like. So it looks like +pi over 3, so it's actually -pi over 3. So let's pull that back. We're going to go -pi over 3. Okay, and then my period is period of the parent function, which for secant is 2 pi, divided by my b value, which is 3, that coefficient on the x. And so that's my period. I'm going to take that period come down here to my interval and take the 2 pi over 3 and divide it by 4. Remember, dividing it by 4, if you make that a fraction, is the same as multiplying by 1 over 4. 2 goes into 4 2 times, so that's going to be pi over 6. So my interval is pi over 6. So starting at negative pi over 3, counting by pi over 6. So my common denominator is going to be a denominator of 6. So negative pi over 3 is negative 2 pi over 6. So then it'll be negative 1 pi over 6. Then it'll be 0. Then it'll be pi over 6. And then it'll be 2 pi over 6, which simplifies to pi over 3. Remember, from our phase shift, our starting point, we're going 1, 2, 3, 4 equally spaced points. Okay, it's good to see an example where we go negative. Okay, so we haven't seen that in class, so it's good to practice that. I'm going to go ahead and extend my midline, showing it going backwards to help me find those points. Okay, and now I'm going to go ahead and graph with a dashed line the reciprocal function cosine. So this is a negative cosine function. So a negative cosine function is going to start at its minimum. So at negative pi over 3, I'm at the minimum down at negative 1. Then it's going to be midline, then maximum, then midline, and then minimum. Okay, so with a dashed line, that's my cosine function, one cycle of it there. Now let's go ahead and do 2 cycles because they often want us to do 2 cycles. So I'm going to go 1, 2, 3, 4 more equally spaced points, counting by pi over 6. So pi over 3 was really 2 pi over 6, so that'll be 3 pi over 6, which simplifies to pi over 2, 4 pi over 6, which simplifies to 2 pi over 3, 5 pi over 6, and 6 pi over 6, which simplifies to a whole pi. Now, if you take a look from pi over 3 to pi, that's 2 pi over 3, which is what our period should be. So you can check and see if you counted correctly, because the length from beginning to end of a cycle should be the same as your period. Now, I'm going to back those marks off just so I don't have extra marks in the way, but it's nice to check your period to make sure you counted your interval correctly. All right, so I'm going to keep going. So negative cosine starts at minimum, midline, maximum, midline, minimum. So if I connect those again with a smooth curve dotted line, because this isn't my actual graph, this is what I'm going to flip to get my actual graph. So to get my actual graph, here we come now in blue. Everywhere where my original reciprocal function, cosine, is at the midline, I'm going to put in a vertical asymptote. So I have a vertical asymptote at negative pi over 6, a vertical asymptote at positive pi over 6. And again, those are 2 of my 5 key points. I'm going to go ahead and do for the second cycle. So when it was at the midline, I'll get a vertical asymptote. Notice that the midline now is up at positive 1, right, because of our vertical shift. So everywhere where it's at its midline, we get a vertical asymptote. Then when it's down, it flips down towards that asymptote. When it's up, it flips up. So we get, like, I call it that little smiley face or happy when you're up, and that little frowny face or down when you're down. So when it's up, we'll flip it up. And when it's down, we'll flip it down. And that's 2 cycles of this secant function. I hope that helps. Good luck on your practice. Come with any questions.